Alright guys, a quick guide to surds. So this is a surd. Basically, whenever you see a root, it's basically a surd. Remember, just think of this sign as a square root, okay? So you just think of this as square root of 16. So simplify the square root of 16. Well, the square root of 16 is just 4, because 4 times 4 is 16. Here, simplify the square root of 200. Well, if you put square root of 200 into your calculator, you get some really nasty number. So basically, there's two ways to simplify. First, you can either square root it if it's a nice square number, like square root of 16 is just 4. But 200, you can't really square root it. So another way you can simplify is make the root as small as possible. How do you do that? You break it down. You think of two numbers that make 200, where one of them is a square number. So you can use 4 and 50, you can use maybe 10 and 20, but is 10 a square number? No, because if you square root 10, you get some nasty number. If you square root 20, you also get some nasty number. So it has to be one of the numbers, no, it has to be a square number. So what I do is I like to think of what are my square numbers? Well, there's 1, 4, 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. I'll just put the first 10 square numbers. So one of the numbers must be one of these numbers. So I know, oh, and it should be the largest number possible. Well, 100. So we can say, oh, the square root of 100 times the square root of 2 is square root of 200. The square root of 100 is 10. The square root of 2 is some nasty number. So we'll leave it as root 2. And we just combine them together, 10 root 2. And that would be your final answer, okay, guys? When you do this, a common mistake is people get overwhelmed. They do it, and they think, okay, we'll do root 2 and root 100, which is perfect. Root 2 stays like itself. Root 100, the square root of 100 is 10. And we're like, what do I do here? The order doesn't matter. 10 root 2, 2 root 10. Just put a number in front and the root second, okay? Just like that. All right. The next one, 3 root 12. Now, the difference between this question here and this question here is that there's a number in front. What we're going to do is that's basically called our third wheel. So 3 root 12 means 3 times root 12. We're going to ignore the 3 for now. Ignore the 3. Just look at the root 12 and let's simplify that. So what two numbers make 12? Well, let's look at our list. Well, the largest number is 4. So we know root 4 times root 3 is root 12. The square root of 4 is 2. The square root of 3 is some nasty number. So root 3. And then we're going to get our third wheel and bring it down right at the end. So don't forget this part. The 3 is still there. It's the third wheel. Don't forget your third wheel. And we're going to do 3 times 2 root 3. And then 3 times 2 is 6. And root 3. And that will be your answer. Okay, next one. Simplify root 6 times root 8. First thing you're going to do is you're going to multiply the surds. So root 6 times root 8 is root 48. And then you're going to simplify. So multiply and then simplify. So root 48. Let's get our list of numbers. Let's look at our list of square numbers. So I know it's 16. So I know it's going to be root 16 and root 3. 16 times 3 is 48. The square root of 16 is 4. The square root of 3 is some nasty number, so it'll stay as root 3. So our answer is going to be 4 root 3. And that'll be our answer. Next one, simplify root 5 times root 20. Well, 5 times 20 is 100, so root 100. The square root of 100 is just 10. That's just the final answer. Nice, easy. The square root of 100 is 10. Here, simplify 3 root 5 times 2 root 10. Well, I know 3. So what you're going to do is you're going to multiply the outside numbers. 3 times 2 is 6. And then you're going to multiply the roots. Root 5 times root 10 is root 50. And then simplify. Let's look at our list. The largest number is 25. Root 20, square root of 25 is 5. Root 2 is just root 2. So 5 root 2. And then your third wheel. Don't forget your third wheel. 6 times 5 is 30. Root 2. Boom, we've simplified. We've made the root as small as possible. So that's what simplifying is. Making the root as small as possible, or just getting rid of the root entirely. This one. Oh, crap. Now, how do we add and subtract roots? So I'll make this a subtraction question. Now, adding and subtracting is not as simple as multiplying and dividing. when you add and subtract roots, the roots have to be the same, okay? So you can add this, root 3 plus root 3. Look, the roots are the same. So root 3 plus root 3 means there's just going to be 2 lots of root 3, basically. So, or 2 root 3 plus 5 root 3. Oh, the roots are the same. 2 lots of root 3s plus 5 lots of root 3s is 7 lots of root 3s. Or you can subtract it. 10 lots of root 3s minus root 3. Well, root 3 just means 1 lot of root 3. So 10 lots of root 3 minus 1 lot of root 3 is 9 lots of root 3. All right, so nice. The roots are the same, just simple. Just combine them. It's like adding and subtracting like terms. X plus x is 2x. 2x plus 5x is 7x. 10x minus 1x is 9x, okay? But, oh, I should have left that there. But the issue here, guys, is that the roots aren't the same. What can we do? We're gonna simplify. Basically, guys, in a search topic, when in doubt, simplify, okay? You don't know what to do? Just simplify. So let's look at root 63. So root 63, I know the largest square number is 9. So root 9 and 9 times 7. Square root of 9 is 3. Root 7, 3 root 7. 28. Shoot, I don't know. 4, 9, 16, 4. Cool. So root 63 is 3 root 7. Root 28 is 2 root 7. And now we can add them up. Look at that! Our roots are the same. Let's go! So 3 lots of root 7 plus 2 lots of root 7 is 5 lots of root 7. Boom. And that's done. This one here, I'll do it in silence. Don't forget your third wheel. I'm starving. I want dinner. Square root of 16 is 4 root 3. And then, yeah, 4 root 3. So minus 4 root 3. 10 root 6 root 3. Boom. Next, expanding brackets. So if you know how to expand brackets, you're going to be good. So remember, you get the term on the outside, and you multiply it by both terms on the inside. All right, so root 10 times 5 is going to be 5 root 10. And root 10 times root 5 is going to be root 50. So root times number, we can't really combine them, so we just put them next to each other. And then a root times root, you can just multiply them. Root 10 times root 5 is root 50. Boom. And then we think, can I simplify this? Well, let's look at 5 root 10 first. Let's write down our square numbers. 1, 4, 9, 16, 25, Do any of these numbers go inside 10? And 1 doesn't really count. 1's redundant. No. So this is fully simplified. It's just going to be 5 root 10. Root 50. I know 25 goes into it. So 25 and 2. Square root of 25 is 5 root 2. So it's going to be 5 root 10 plus 5 root 2. Are the surds the same? No. Can I simplify this anymore? No, we tried to simplify. It didn't work. So this will be our final answer. 5 root 10 plus 5 root 2. Next one. Simplifying double brackets. How do you expand double brackets? You got to use your FOIL, gangsters. FOIL. First. Out. In. Last. So the first terms. 4 times 3. 12. Outside terms. So 4 and positive 8. So plus 4 root 8. Inner terms. Negative root 2 times 3. So minus 3 root 2. And then last. Negative root 2 times root 8. So remember, it's negative root 2 times root 8. So the last term in each bracket. Root 2 times root 8 is root 16. And the negative and the positive is a negative. Negative root 16. Boom. Let's simplify this. Well, that's 12. Let's simplify 4 root 8. I don't know. Root 4 and root 2. The square root of 4 is 2. Root 2 is just root 2. Don't forget your third wheel, guys. Bring that 4 down. Boom. 2 times 4 is 8 root 2. Good job. And then, can we simplify 3 root 2? Well, root 2, what numbers go into 2? Well, we know, we can't really simplify it because only root 2 times root 1 makes root 2. Can't really simplify root 2. Square root of 1 is just 1, so that's redundant, so it doesn't really work. So it just stays as 3 root 2. The square root of 16 is 4. So let's have a look at what we have now. So we have 12 plus, instead of 4 root 8, we're going to do 8 root 2 minus 3 root 2. We couldn't simplify root 2. Minus square root of 16 is 4. A common mistake here, guys, is people think the square root of 16 is square root of 4. No, the square root of 16 is just positive 4. And then we're going to combine the like terms. So 12 minus 4 is 8. 8 root 2 minus 3 root 2. 8 lots of root 2's minus 3 lots of root 2's is 5 lots of root 2's. Boom. All right. Boom, boom. Oh, rationalize the denominator. Damn, what does rationalize mean? Oh, shoot. I should have given it a full title. My bad, my bad. Poor form. Rationalize the D. Oh, God, it smells good. All right, anyways. Rationalize the denominator. Let's break down those. Let's break down the vocabulary. What's a denominator? Well, it's the bottom part of the fraction. So we're going to be focusing on the bottom part of the fraction. Rationalize. What does rationalize mean? All right. Now, this is a surd. Another name for this is a root. So another word for a root is it's an irrational number, all right? So what we have to do is we have to rationalize it. To rationalize means to get rid of the surd. So that's our goal. Get rid of the surd at the denominator. Look at all three of these denominators. There are surds. So our goal is to get rid of the surds. That's the goal. There could be a surd on the top. That's fine. But the question is rationalize the denominator. So get rid of the surd at the denominator. How do you do that, guys? All right. So now, when there's a surd at the bottom, just a single surd at the bottom, it's really easy. Later on, we're going to do things where there's like a number being multiplied to a surd or a number being added to a surd. Don't worry about that now. When there's a number just at the bottom, what you're going to do is you're going to multiply the bottom by the surd and multiply the top by the surd. That's it, guys. Easy peasy. 5 times root 2 is 5 root 2. Root 2 times root 2 is square root of 4. 5 root 2 over the square root of 4. Let's simplify that. Well, look at that. The square root of 4 is just 2. So it's just going to be 5 root 2 over 2. Now, what we're going to do is look, this. I see two terms, the top term and a bottom term. We're going to focus on just the integers, just the whole numbers. Can we simplify 5 and 2? No. That's our final answer, okay? Easy peasy. Next one, same thing. Rationalize the denominator. So how do you get rid of root 6? You're going to times it by itself and times this by itself. Actually, I'm going to change it to, instead of 7, I'm going to use 10. 10 times root 6 is 10 root 6. Root 6 times root 6 is root 36. 10 root... Oh, let's look at the top. Can we simplify 10 root 6? Any square numbers that go inside 6. So I know we can do root 1 times root 6, but root 1's pretty stupid. Doesn't really work. The next square number is 4. But 4 times nothing makes root 6. So we can't simplify 10 root 6. The square root of 36 is 6. So we can say 10 root 6 over 6. Let's look at the integers. What can we divide both numbers by? We divide both numbers by 2. So 5 root 6 over 3. All right, gangsters. Next one. Oh, look at that. Surd at the bottom. Times it by itself. Root 5 times root 5. All right. So we're going to do this times root 5. I like to write it like this. Root 5. And then in brackets, root 2 plus 1 over root 5 times root 5 is root 25. Let's expand the bracket. So root 5 times root 2 is root 10. And root 5 times 1 is just root 5. And the square root of 25 is just 5. Can I simplify the square root of 10? Well, let's write down our square numbers. 4, 9, 16. Well, 1 doesn't count. Does 4 go into 10? No. Does 9 go into 10? No. We can't simplify that. How about with 5? Does 4 go into 5? No. Does 9 go into 5? No. Root 10 just means 1 root 10. Root 5 means 1 root 5. Can we simplify the integers? 1, 1, and 5. What can we divide all three numbers by? Nothing. Boom. We're done. All right, gangsters? We don't need those ones. Boom. All right, let's compare these. Oh, sorry. Let's see these. Rationalize 3 over 2 root 5. Let's compare this question here to the last set of questions. What do you notice? Look at focus on the denominators. Here, that was just single roots. Square root of 2, square root of 6, square root of 5. Now, there's a number being multiplied by root 5. So 3 over 2 root 5, 9 over 4 root 7. But guys, when there's a number being multiplied by the surd, it's the exact same thing as before. All you're going to do is you're going to multiply by the root, okay? You're not going to multiply by 2 root 5. You're just going to multiply by root 5. Same thing for the top. So 3 times root 5 is 3 root 5. 2 root 5 times root 5. Root 5 times root 5 is root 25. So 2 root 25. Let's try and simplify 3 root 5. So we just think, can I simplify that? Let's write down our square numbers. 1, 4, 9, 4 times 4, 16, 25. We don't use the 1 ever. Does 4 go into 5? No. So therefore we can't simplify that. How about the bottom? The square root of 25 is just 5. So it's just going to be 3 root 5 over 2. The square root of 25 is 5, so times 5, which is equal to 3 root 5 over 10. Then, let's look at the integers. Any common factors? Nope, then we're done. This one, same thing here. 4 root 7 times by root 7. Times by root 7. 9 times root 7 is 9 root 7. Root 7 times root 7 is root 49, so 4 root 49. So it is... We simplify the bottom, 9 root 7. Well, does 4 go into 7? No. So therefore, we can't simplify that. The square root of 49 is 7, actually. So 4 root 7 over 4 times 7. 9 root 7 over 28. Look at the integers. Can we simplify 9 and 28? No. Then we're done. Boom. Boom. Last page, guys. Come on. Now, what do you notice? Is it a root by itself? No. Is 3 being multiplied by root 2? No, 3 is being subtracted by root 2. Whenever you see a number being subtracted or added, this is the third level of rationalization. In this case, whenever you see a number being added or subtracted, what you're going to do is you're going to multiply it by the opposite. So instead of multiplying by 3 minus root 2, we're going to do 3 plus root 2. And then the same thing on top, 3 plus root 2. So let's expand the brackets. So I see brackets, so 3 times 3 is 9. 3 times root 2 is positive 3 root 2. Here, I'll put this in brackets. So once you put in brackets, you see you have to use FOIL. First, outside, inside, last. How you expand double brackets. F stands for first, so first terms. 3 times 3 is 9. O stands for outside, the outermost terms. 3 and positive 2. Positive root 2 is plus 3 root 2. Inner terms. 3 times negative root 2 is negative 3 root 2. And the last terms. Root 2 times root 2 is root 4. Negative and a positive, the negative overpowers it, so negative root 4. Let's simplify. So the top's just going to be 3 root 2. Bottom, plus 3 root 2 minus 3 root 2. So since they're both root 2's, we can subtract them. So 3 root 2 minus 3 root 2. Well, 3 minus 3 is nothing, so it just cancels out. So these just cancel each other out. 3 root 2 minus 3 root 2 is nothing. So it's going to be 9 minus root 4. The square root of 4 is 2. So it's going to be 9 plus 3 root 2 over 7. Let's look at the 3 root 2. Can we simplify 3 root 2? Well, what square numbers make? Let's write down our square numbers. So 1, 4, 9, 16, 25. We don't count 1. So we can't simplify that because 4 doesn't go inside 2. So therefore, no other numbers go inside 2. So it just stays as 3 root 2. Let's look at the integers, 9, 3, and 7. Anything in common between 9, 3, and 7? No. So we're done. Next one, root 11 plus 3. So we're going to do root 11 minus 3. So we're going to do root 11 minus 3. So what you do to the bottom, you do the exact same to the top, okay? 3 plus root 2, 3 plus root 2. Then we're going to use FOIL. So first, root 11 times root 11 is root 121. Outside, root 11 times negative 3 is negative 3 root 11. Negative 3 times root 11 is negative 3 root 11. And negative 3 times negative 3 is positive 9. Over, first, root 11 times root 11 is root 121. Outside, root 11 times negative 3 is negative 3 root 11. Positive 3 times root 11 is positive 3 root 11. Positive 3 times negative 3 is negative 9. Let's simplify this. The square root of 121 is 11. Minus 3 root 11 minus 3 root 11. Since they're both root 11s, we can subtract them. So minus 3 is minus 6 root 11 plus 9, which is, and then 11 plus 9 is 20. So 20 minus 6 root 11. Bottom, the square root of 121 is 11. Minus 3 root 11 plus 3 root 11. Since they're both root 11s, we can combine them. So minus 3 plus 3 is 0, so that just cancels out. Minus 9, so it's 20 minus 6 root 11. 11 minus 9 is 2. Let's look at the numbers, 26 and 2. I can divide all those numbers by 2. So 20 minus 3 root 11, 2 divided by 2 is 1. Anything over 1 is itself, so it's basically equal to 10 minus 3 root 11. Boom. So look how we rationalize everything. We started with 5 over root 2. Now it's 5 root 2 over 2. There's no more surd at the denominator. No more surd at the denominator. No more surd at the denominator. 3 over 2 root 5. It ends up like this. No more surd. We rationalize the denominator. We rationalize the denominator. Started off with this, ended up with this. No surd at the denominator. Start off with this. There's a surd at the denominator. Look at our answer. We don't even have a denominator, so we've rationalized everything, guys.